Hello everyone, and once again you welcome back in a Cypenepal. So today we have came with a very wonderful topic, that is a flat slab. So how can we do the design and analysis of a flat slab by using a Cype software? As you can see, this is a plan of the commercial building. And so how can we do the design and analysis of flat slab by using a Cype software? And let me define you the flat slab. Flat slab is defined as a two-directional reinforcement slab where there is no beam, no girder, and that's the definition of a flat slab. If you see the applications, sometimes we require for the constructions of the parking deck, commercial building, that is a bank, office, hotel, as well as a warehouse. These are the applications of the flat slab. And you can see this is a plan of a commercial building. As you can see, this is also plan of the commercial building, but this is a plan for the conventional slab we can use in this building. And this is a call layout that I have created for this plan. This is called a layout. So if you see the image, this is the image of the flat slab. And so how this flat slab can be the design and analysis, and these are the image of the flat slab. You can see the clear here. So how can we do the design and analysis of flat slab by using a Cype software? As you can see, so if you see the IS code 456-2000, if you see the page number 53 and 54, we get the what is the method for the constructions and what is the requirement for the construction of the flat slab. And this is one of the powerful codes of the Indian standard also. If you talk about the NBC, that is a Nepal standard, and 205 and page number 25 and 26, if you see, we'll get some method for the construction of the slab. And you can also talk about the ACI also, 318, and this is one of the powerful code in the world. And you know the tallest building in the world, that is a Burj Khalifa, and this whole building is depends on this code only. And UVC also, you can see the page number 690, and there is some method we have for the constructions of the flat slab, and these are the considerations. And if you see the methods, we have the 4 methods for the construction. First one is we only require the panel drop, and so second methods we have only the column head, and third methods we have both the combinations of the panel drop as well as a column head, and last one without panel drop and without column head. These are the methods of the flat slab. So if you see the design of the flat slab, we have the 2 methods. One is a direct design method, and another is a equivalent frame methods. So these are the methods. So let we go to the Cype software, and you can also talk about the what is the IS code says. So if you see the codes, what the code says regarding the flat slab. So at first we are talking about the thickness. The thickness we have to consider the minimum thickness for the flat slab is 120 mm, and for the conventional slab we only consider some codes it says that the 80 mm and 100 mm. And if you consider the live load should not be greater than the 3 times design dead load for the flat slab, but such types of the rule we don't have in a conventional slab. So these are the considerations we have to study, then only we are able to design an analysis of the flat slab. So let's go to the software, and we explain you the more through the software. And you can see the similar way we have done this project by using a Cype software, and you can see the 3D model also. And you can see this is called panel drop that we have done in this project. So let you how can we do all the things, and which is a requirement for the constructions of the flat slab. So let we go to the software, and now you come to the Cype software, and this is a Cype software. So before that, I am going to talk to you about the plan. This is a plan of the flat slab, and you can check the dimensions. So now I am using AutoCAD 2020. So you go to the utilities and measure and quick measure. You can measure the distance that we have the 8 meter here to the center to center, a spacing of one column to another column. We have the 8 meter here, so we can measure in AutoCAD. And we have the panel dimensions also. You can check this is 2 meter by 2 meter, and column dimension only the circular as well as a square column we are going to take for the flat slab. We don't go for the rectangle column. So you go to the software, and you can see this is a Cype software. At first we have to start from the CYPECAD. So you go to the CYPECAD and give the right click here and go to the new. Just type the name of your project. Yes, I am typing. So simply give the accept. Beam model we don't have, so give the no here. And we go for the MPT project, so simply give the accept. And you can see the code here. We have the different country code, and now I go for the Indian standard only, that is IS 456 2000. Just simply give the accept here and give the accept, give the accept, give the accept. Now we can change the background color here, so better to go for the configurations here. So and you go for the background color. Thus I am going to change the color here. So at first we are going to import the DWG file format. So you go to the edit template, and you go for your file where you have saved. This is my file. So simply give the accept and give the accept. And now you can see this is my plan in AutoCAD, and I have imported this file in a Cype software. As you can see, this is a Cype software. I have imported this file in a Cype software. So at first we have to create the floor. So you go to the introduction, or you can use this new floor options also, but now I go for introductions and floor and new floor. Give the single layer. And now I am going to take a height, that is a clear height. I am going to take as a 4.5, and live load I am going to take that 3.5 kilonewton per meter squares, and direct load I am going to take 1.5. So and two floor I am going to consider here. One story we have to consider for the foundations also. And later I am going to change it. So again you go to the edit floor options we have, and now I am going to take 1.5 meter. So again you go to the minus 1.2, and you can see this is the foundation levels we have. So simply give the accept here, and again you go to the edit group, and in this here we don't have any slab here, so I am going to change the load, that is a 0, and just give the accept here. And now you come to the, we have to arrange the column also. So you go to the introductions again and column options, new column, or you can go from the short commands also. We have the new column options here, and you can type. And what is your dimensions of the column we have? I have already told you that is a 45 cm by 45 cm we have. So again you come to the software and give the 45 cm here, and simply give the accept. We go for the voice snap also, and active your voice snap and clear all. We are only going to select the in points, so simply give the accept here, and you can save the column here. And you can do a similar. After putting the column, we have to bring the column to the proper positions. So we have the options here. You go to the adjust and simply give the accept here, and you can bring your column at the proper positions. In this way we can do all, and in this way you can arrange the column as I have shown you how to arrange in a proper position. Then you come to the beam definition, and you can see we can on the, you go to the edit view here and tick these options and you get the plan once again here. So what we have to do, we are working in a top floor, that is a floor 2, and you can on your plans here also. And so at first I am going to create the slab here, so you go to the slab and we have to go for the beam also. You go to the beam and you select the non-structural beam we have, and we go for the, we can change the justifications also. You go to the OS snap again and just untick the endpoint and select the nearest one, and you can do, and you can on the ortho also. You can on the ortho and simply you can do here. Now you go to the extend options we have and just extend. Okay, and you can trim the outer line. Just I'm going to trim this. Now you can go for the slab, so slab panel and new slab and give the 24 cm. Just simply give the accept, and you can see in a 3D what we have done. And you can see in a 3D. And so again what we have to do, we go to the ground floor again, and we have a simply the beam here. So you go to the beam options, we have a defined beam, and you can select the beam. Thus I'm going to take the 30 cm by 45 cm. This is tie beam we are going to take, and just you can go for the simple also, and we go for the OS snap also, and just select the nearest one here, and you can change the justifications also. So I'm going to check the justifications, change the justifications here. After putting the beam, we are going to delete the extra portions, that is after putting the tri beam, we can see in a 3D what we have done, and this is a 3D model. And here we don't have, at the ground floor we don't have any slab, so you go to the slab again, slab panel, and you go for the delete options and select all, and again you can see in a 3D what we have done, and this is called tie beam. So again you go for the analysis again, go for the analysis. After the analysis you just close this and we go to the result, and you can off the plan here and you go to the next floor, and you can check the punching here also, and you can check the punching here. We have the failure here, so what to do? So that's why we require the panel drop. So pinching shear is defined as the shear failure of a structural member or slab or foundation due to the high load or force. This is called a punching shear. So for the to minimize the error, that's why we required the panel drop. And you can see in an image, if you are not going to minimize, then the structure might fail. You can see in an image, this structure have been failed due to the punching shear. That's why we require the panel drop as well as a column head we required to minimize the error of the punching shear. So again, what we have to do, so again you go to the this edit view, and you can arm your plan here. And so what we have to do, you go to the beam definition, and you go to the beam, and so you can select your non-structural beam. That is a non-structural beam. Just simply select here, and you go for the snap, and we are going to create the one slab here. So simply just select. And you go to the slab and slab panel, define a slab panel 24 cm. We are going to take this slab, and again you come to the slab and give the 45 cm here. Just give the simply accept here, and we can change the dimension of this slab. So again you go to the copy option and select this slab, give the simply accept here, and you can select all the panel here. And again you can see in a 3D what we have done, and you can see this is called a panel drop. So again you go for the analysis. After the analysis, you close this, and you come to the result again, and you can check the punching shear. So you just go for a check and check, and you can check here we have minimized the punching shear here. And then after what we have is sometimes we require the additional reinforcement also. You can do from by here also. You can introduce this, just type the name, and you can select the diameter of a bar, and just simply give the shape here, and you can tick. So additional reinforcement, if we require, we can go for that. So for the additional reinforcement, you can select, and you can put if the additional reinforcement we require for the punching shear, then we can go for this. So now you can see in a result also, you go to the deform shape, and just you on the slab here, and you go for the combine, and you can check the deflection. So this is for the temporary deflection, that is a 7.7 mm here, you can see here. But for the serviceability of a building for the 30 years, we consider this is 8 mm, multiply by 3. it is 24, but for the limit for the deflection, if you say the IS 456 2000, the limit for the deflection is span by 250. The spans we have the 8 meter here, you can see 8 meter span we have, and we have the 8 meter here. You can see we have the 8 meter to center spacing of one column to another column. We have 8 meter, so 8000 mm divided by 250, it is 32. But we can come to the software again, and we have a 24, that is a total deflection. So in this way we can consider the structure is safe in a deflections. So again you come to the result, and you can check what is the reinforcement in a slab. So just you off this, and you can check in a slab what is the reinforcement. You go to the longitudinal top, bottom, and you simply give the accept here, and you can see the reinforcement. But if you see these types of the reinforcement, it become confused for the constructions. So how can we can go for the second method also. So better to go to the flat and waffle slab. Here we have a base reinforcement methods we have. So I'm going to select we are going to provide the reinforcement, that is a 12 mm at the center, 250 mm center to center. So we are going to provide the already reinforcement we are going to provide to the structure. Then after we are going to see what might be the result. So we have to make the setting also here. So you go to the bar options we have here, base reinforcement we have, just of these options, and you just simply select. And again you can go in a slab, just give the simply accept. You go to the beam definition again, and in a slab you can check. So panel data we have, just simply select, and you can see here we have already provided the reinforcement, that is called the base reinforcement. And again you can go for the analysis. You go to the analysis again, and just simply give the accept here. After the analysis you close this, and you come to the result again, and you can check the reinforcement. This is the extra reinforcement that we require, and I have already told you we have provided some reinforcement, and you can check the panel data, and this is a shear reinforcement, or we can also call this is a base reinforcement that we have provided. We have provided this reinforcement, and we give the analysis. After that, only the few reinforcement we receive or we get by the software, because this is extra reinforcement that we require. And you can check in a longitudinal top also, you can check, and this is a top reinforcement. Or if you have the confusion here, if you have some confuse here, then you go to the modify distribution, and just select this and select this bar. You can erase the bar only, and you can also move the reinforcement, just move options we have. And you can see we have already provided the base reinforcement, that is a 12 mm 150 mm center to center spacing. We have already provided the base reinforcement, and in this way we can complete our project. And you can go to the foundations levels also, and this is my foundations level. You can provide the foundations here, but now I am going to off the plan here, so simply off the plan. And you can provide the foundations also. You go to the foundations, new foundations, and you select the square one, because the size of the column we have the square only, and select all the foundations here. After the foundations, you can go for the strap beam also. So simply give the S here, and you can select the balance one, and you can track from here to here. And again you go for the foundations and design, and give the accept here. And you can check the reinforcement in the foundations also. You go to the foundations, edit, and select the any foundation. You will get the reinforcement detail, and this is a reinforcement detail. You can also view the 3D model, and this is a 3D models. And you can also check the what is the strap beam we have. So you go to the strap tie beam, just simply give the edit and edit here. You can view in a 3D also. So in this way we can complete our project. I think I have discussed you each and everything which is a requirement for the construction of the flat slab. So if you have any comments, you can Gmail me cypenepal@gmail.com if you have any confusion regarding this project. So, and we have received the same mail from Sunil Giri and Pramod Pandit. So they have some confusion regarding the software. So I'm going to explain you something regarding what they have the questions. And so I'm going to take the example of the other project. This is a project we have done. So simply you can change the background color. So I'm going to select this one. So but here have the problem, how can we do the work according to the Nepal standard? So simply you go to the any project you can complete in a Cype. Just select the beam, any beam, and he have the problem that the why the spacing is not different. So I'm going to take it to the manual. How can we do the manual according to the standard of the any country? So simply you delete all the reinforcements. Just I'm deleting all the reinforcement here. So delete all the reinforcement, and you go to the introductions of the new reinforcement here. You simply just select the reinforcement here and give the I'm going to take a 12 mm and both top and bottom. And for the transverse reinforcement we can go for the 8 mm. So simply give the accept here, and we can provide the hook also. Just simply give the arrow we need. And you can check here how we have the stress. We have the stress, more stress here. That's why we have we require the more reinforcement here. So I'm deleting this reinforcement. So I'm going to take additional reinforcement here. That is 12 mm and 2 numbers I'm going to take here. Simply give the shape, and you can draw from here to here. And in the similar way we can do here also. And we can we have the maximum movement here, so also we can go for this. So I am going to select the 12 mm of 2 numbers, and the bottom reinforcement we can provide here. So simply give the accept here. We can do for here also. And in this way we have to also provide the some reinforcement here. We have the high stress here, shear stress we have. So you can go for the, and we can also change the spacing very easily. So you go to the transverse reinforcement here, and simply we are going to divide the span. Thus I am going to divide the span from here to here. And you can change the spacing. So I am going to edit the, so I am going to simply type here the 10 cm, and midway have the 150, and we can also change here. This is 10 cm we have. So simply give the accept, and you can update and simply give the accept, and you can change. We have the spacing, high spacing. These are confusion regarding, he have the confusion, that is a Pramod Pandit. We have received your mail, but by the way, thank you for your mail to our Nepal, because this fellow also belongs to Nepal. So I have done, and this is a Nepal standard. This is a NBC, and yeah, this is a NBC. So according to the NBC also we can do by this software. And we have also next mail we have received from Sunil Giri, and he comments, we don't receive any mail from him, but he comments how can we do the layout, or every time we have to only import the DWG file format, or we can do by the Cype also. So how can we do by the Cype? So go to the new, just simply give your project name, just give the accept. Beam model we don't have, take the MPT project only, and simply give the accept here, and give the accept. So we can create the layout also here. So at first we have to create the floor. That's why I'm going to take only floor height, that is 4.5 meter, dead load 2 kilonewton and live load 1.5 kilonewton, and simply give the accept. So you go to the new column options we have, so simply give the accept here, and you can put the anywhere you want. Just I put the here only. This is a column size we have, and if you want the next column, you go to the, you select this option and give the right click here, and it asks for your distance. Just I am going to type the 4 meter here and give the enter. In this way we can create the layout in a Cype software also. And he have comments, and that's just Sunil Giri. He have comments regarding the how can we create the layout in a Cype also. So each and every time we should not have to go to the AutoCAD when we have to draw. We can do in a Cype also, but if you import the DWG file format, it increase your work, it increase your easiness in a software. So in this way we can create the very easily. Again you go to this select this line and give the here right click and give the type the distance of the one distance between the one column to another column. Just give the enter here, and you can create the layout also here. So we hope each and everything we have explained regarding the flat slab. So also you can check what is the result also, and you can check the column design very easily by the software, and you can check the reinforcement, what is the reinforcement required, and you can also check the what is the manual design by the software very easily here. And each and everything you will get by the software. If there is some error, you will get the red mark, but we don't have any red mark. So in this way we can do the project that is regarding the flat slab by the using the Cype software. So now at last we are going to introduce you the some leaps, and which helps you just simply. So you come to the AutoCAD, and I am going to introduce you the some leaps, and this is my leaps, and which helps you to draw the cross sections as well as of footing details or structural detailings of the footing. We can get the very easily by the using the leaps. So you go to the AutoCAD, and you can go from the manage tab also. You load the applications here, but you can go for the commands also. You just type the AP commands and just give the enter, and you can upload your leaps. And this is my leaps that I am going to upload here. So give the load, and just simply give the close here, and you go to the command again and just type the COL column and just give the enter, and you can select the any points. So just I am going to select the any points for Windows, in AutoCAD window. Just I am going to click here only, and you can come here also. Just see what I am going to type. Just type the 0.6 here, 0.6 and 0.6, and just sorry just type in a command COL and just give the enter, and you can select the any points. Thus I am going to select here, and simply you come to the points. That's the base I am going to take as 0.3, just give the enter, and for the height 0.6, just give the enter, and number of the bar I am going to take as a 6 bar here, just give the enter. Layer 2 layer I am going to take, diameter I am going to take as 16 mm here, and column name just I am going to give the COL one and give the enter. And you can see in AutoCAD the ellipse automatically draw the cross sections of a column. So we can also work with the help of the ellipse. Also we can get the structural detailings regarding this column also. In this way we can do, and we can also go for the footing also. The same ellipse work for the footing also. Just give the FOOT foot commands and just give the simply enter, and you can select AutoCAD anywhere. Just I am going to select here only, just simply give the selection, and you can type the whatever I am going to type here. Yes, simply that is the base of the footing, that is a 2 meter I am going to take, just give the enter, and vertical that is 1.8 meter I am going to take here, and thickness that is a 0.6 and give the enter, and column that is going to take I am going to take 0.3 and 0.6, and the number of bar I am going to take as a 6 bar, give the enter here. Layer 2 layer, and column diameter I am going to take as a 16 mm, and horizontal spacing I am going to take as a 20 cm, and bar diameter I am going to take as a 12 mm, and vertical 1.8, and give the enter. Spacing 18 cm, give the enter here. Bar 12 mm, and footing name just I am typing the footing name and just give the enter. You can see in AutoCAD what we have done. So in this way we can create the structural detailing of a footing as well as a column dimension with the help of the ellipse. So this is a very wonderful ellipse we have. So we share the link in a description, and you can go and you can download and you can try yourself, which might be the helpful. So we are also going to talk about the Excel sheet, and which helps you to create the longitudinal sections of the beam. So you go to the new window here, and simply you go to this Excel sheet, and you can change the dimension which is a requirement for your project. You can change the dimension each and everything which is a requirement for the construction of your project, and simply you give the draw here, and you can come to the AutoCAD again, and you can see here this Excel sheet draw the longitudinal sections of the beam. So two new things we have introduced you. The one is the Excel sheet and another is ellipse. So you can download, we leave you the link, and you can download and you can try it yourself. So now we have already explained you each and everything regarding the flat slab. So if you have any comments, then please you mail us or comment us. Okay, thank you for watching, and take care, stay well.